right, welcome back. If you just finished the previous slide, day 3, part 1 slide here, you have been made familiar with the simulator of the skate park, all of the different features that it has, and you are ready to show what you know here. So, first one is talking about using the U ramp here. Place your skater at the top of the ramp. Pay attention to what is happening on the bar graph, circle graph, and speed, and then click here to answer some of your questions regarding your observations. So let's do that right now. Let's click on this form here. All right, and then over here we have some general questions. First your name, and then over here talking about what was the color of the kinetic energy and what's the color of the potential energy. So if we go back to the energy skate park over here, this is what we're talking about at the top of the page. Energy, kinetic energy, and potential energy. Also, if you put your skater back on, and you're going to see how those different colors change over here in the bar graph. So there we go. Also on the pie chart, see what those different colors mean. I'll stop it right there and go back to our form today. So then you'll be able to answer these questions here. What color was kinetic and what color represented potential energy? Once you've done that, then you're ready for the next question. Where does the skater have the most kinetic energy? And then the question after that is, where does the skater have the least kinetic energy? Let's go back to our simulator. You can keep clicking back and forth to help you with this. I'm going to put it up here, and we're looking for kinetic energy, most and least. So I'm going to hit play again right here, and kinetic energy, as you can see, is the green color. So let's see, where is that at? Is it at the top or is it at the bottom? Let's put it right there. As you can see here, there is a difference, isn't there? Where is it the least and where is it the most? Okay, so once you've got a good idea of what those answers are, you can come back over here and answer those. And then we're going to look for the opposite. We're going to look for where's the least amount of potential energy and where's the most potential energy. So once again, going back to the skate park, potential energy is blue. We can look over here at the bar graphs, or we can look over at the pie chart. And where is the most potential energy and where's the least? Is it at the top that it's the most, or is it at the middle? Where is it the least? Is it at the top or in the middle? Make sure you're paying attention to the blue color there. I'll pause it and go back. So then we're able to answer those questions. The next question is asking you to change your U ramp into an L ramp, like this one right here. So select the L track to answer the following question. Your screen should look like this one right here. In the table below, describe what happens to the potential energy of the skater when she is on different parts of the track. So we're going to look at the highest part, the middle of the track right about here, and then at the very bottom of the track. Okay, where is it the highest? And where is it the lowest? Where is it increasing? Where is it decreasing? Let's look at that now for potential energy. So we're going to come back over here. Make sure you have all of these boxes selected still. Switch over to the L ramp. And let's see. Yep, looks like I've got a pause. Yep. And as we're looking here, what do you notice about the potential energy of your skater at the top? Out there at the middle, what happened to potential energy? Is it getting higher or lower, increasing or decreasing? And then here, what do you notice about the potential energy? Did it increase or did it decrease? Okay, back to our form. Now we're going to look at this same situation. This time we're looking at it with kinetic energy, so the green of the skater when she's at different parts of the track. Make sure you know, make sure that you have either the pie chart or the bar checked. So again, at the high part, at the middle of the track, and at the bottom of the track, what is going on with the kinetic energy? So we'll look at that again. This time Keep in mind kinetic energy is green, so when you're starting at this top part, what do you notice about kinetic energy? High or low? About the middle of the track, what do you notice is happening to kinetic energy? Is it increasing or decreasing? And then at the bottom of the ramp, what do you notice? Okay, so then you can go back and answer the questions. Based on what you've learned and observed, how can you describe the relationship between kinetic and potential energy? So it gives you two choices here. They have a direct relationship, so that means as one increases, is the other one increasing at the same rate? Do they both go up together? Or do they have a negative relationship where when one goes up, the other is going down? Back and forth like this. This would be a negative relationship or indirect relationship. Okay? So select the one that makes the most sense and then hit submit. I'm going to go back to our slideshow presentation. Now I'm on part 3. This one I just wanted to review 3 key vocabulary terms. We're not going to do as much vocabulary work as we have before while we're learning from home, but these 3 words are very important when understanding about roller coasters and how they work. So first of all, let's look at energy. And this is the first thing we want everybody to know when you finish this unit, is that energy is the ability to do work. So if you are running, if you are walking somewhere, you need energy to do that, to move you. If you need to move something, you need energy to move that object. If you want to use your phone needs to have energy. So we see that this is a basic thing all around us, is that we need energy to change things or to move them. And there are lots of different types of energy. We are going to look at the 2 basic types that all the energies fall under, and that is kinetic energy and potential energy. So kinetic energy is any kind of energy of motion. So when you see things that are moving, they have kinetic energy in them. Our skater here had energy. And here, I'm going back here so you can see this. Notice how as she speeds down this ramp, she increases her speed, right? So kinetic energy is looking at a person's speed and looking at their mass, their velocity and their mass. And if we take and change her mass, notice she's going to have a different amount of kinetic energy. Okay, so we'll play that again. So you noticed over here, the kinetic energy shrank when her mass shrinks. So the more mass you have, the more kinetic energy you can have. Same thing with, same relationship with speed. As speed increases, so does your kinetic energy increase. Going back to the slideshow now. So that's kinetic energy, energy that's moving. Potential energy is the amount of energy an object has based on how much it's stored or based on its position. This is usually talking about different types of fields, like electrical fields, magnetic fields, and in this case, in the most common case, is a gravitational field. So as we go up and up and up and up and up and up, notice how in the bar graph over here that her potential energy is increasing. Okay, as she gets farther away from Earth and Earth's gravity, she has more potential energy, more potential to move into kinetic energy, doesn't she? The higher she goes, the faster she's going to end up falling. So we're storing up more and more energy in her as she gets farther away from Earth, or Earth's gravity. It's pulling on her. Okay, so that's a big difference between kinetic and potential. Potential is stored energy based on where an object is positioned in a field, and over here, kinetic energy is looking specifically at its motion, the energy of motion. All right, so those are the 3 words we want to be using a lot of and trying to understand. Those were also in our readings for the last 2 days. If you have any questions about those, please give me an email. And that's all for today. So I'll see you guys tomorrow. Be safe and stay in touch.